Hello Brief Calculus students, I'm going to show you integration by parts, part 2. Brief Calculus meaning no trig functions. Alright, so in the previous video I went over U substitution, how you tell it apart from integration by parts. Of the 3 examples, I left 1 to work, and during this 3rd example I'll show you how to know if something's wrong. And then we'll do repeated integration by parts, which is much simpler if you use the table. So, example 3. I thought it was an easy problem. I mean, we have a natural log, and when I looked at its derivative, we have one of the x, but it's not perfect because we have a 2. And so I said, alright, I'm going to think about it. And I pulled out an x plus 1. So there's really 2 of them there, but I just kind of separate them. And did I do this to make things up? No, when I was working on it. I don't know if you can see it. I wrote a great big no right there. Yeah, I did it wrong the first time I tried. And the second, I mean, who says you have to get it right the first time? But let's walk through this. Okay, so we have our integration sign. We pull up the table. We got the derivative side and the integration side, and usually we just read left to right. So we plop it in, and you see right here, let me just go back a little bit. See, I just put it as 1 over x. 1 over x has that raised to the -1 power. Integrate, beautiful, easy piece of cake. And let's come over here. It got a little messy. This might be a warning sign right here. The derivative is more complicated than what you started with. But let's look through. Okay, so we multiply across, and then it's not too bad. And then we subtract the integration of this multiplied across, and I looked at that and I said, wait a minute, this is the exact same function. Let me back up so you can see. Come on. See, it's the exact same function we started with at the example 1. Come on. So basically we just circled around and added a piece. Well, what was the whole point? So let's try again. Alright, so we know one way that doesn't work. How about we pull all that x squared out? So, or that quantity that's squared out. I'll just go derivative and integration. Just see how this works. So, just writing it across. Okay, derivative. Derivative looks more messy. And how do you integrate a natural log? I'll show you that next. But I mean, I looked at it. I was looking at what is the derivative of a natural log, and that's what kind of clued me in that maybe this wasn't the right method. It just got more complicated. I'm trying to make it easy. So 2 ways that don't work. Now this is not baseball. We don't have 3 strikes and you're out. You don't strike out in math unless you just quit. So there are 2 ways that don't work. It's okay. So I looked at it again. I said, what if we just switch these 2 terms around? So we'll make this one, this piece the one we take the derivative of, and this piece, let's find the integration. So pull up the table and just straight across. Derivative's not bad. Let's see what the integration is. It's actually easier because we had a negative power, and we integrate a negative power. It's a little bit less negative. So just to get, simplify things, make it look pretty. Okay, so let's see if we can put this integration by parts together. So We go across, multiply, make sure that negative's in front, and then subtract the integration. Don't forget to put that integration sign in there. We kind of need it. So, 1 over x. Yeah, so we've got 2 of these x plus 1 pieces. Minus 1. And you know, that looks like exactly what we started with here. And we found the integration as negative 1 over x plus 1. So, as I go through and try to simplify, like make it positive, and maybe put that as a negative 2 on top, and keep simplifying, there we go. It was easy to do once I got the right split. You notice I tried 3 different methods. It doesn't make me a stupid person for not getting it right the first time. It just means I get to be creative and try 3 different ways. So let's blow this away, and I'll show you really can do the derivative of a natural log. Okay, so there's a sneaky little trick. We pull it into 2 pieces by just multiplying by 1. Then we can do our integration by parts. Let's just fill it straight in. And, okay, derivative of natural log is 1 over x. Integration of 1 dx is just x. And we go to use integration by parts. Multiplication, we get x, natural log of x. Then we subtract the integration of x divided by x dx. Which is basically the integration of 1 dx, or negative x, plus c. This isn't something I had memorized, and so I was kind of pleased to read it in the book what it really was, and thought I'd show you guys too. If you want to write it on the notes you get for the final, I'd say go for it. So, repeated integration by parts. This is usually when you have a polynomial like this. So, I can take the derivative, but I want the derivative to go down to like 0 or 1 or 2. I mean, it really gets simple. So all I do is expand the table and start alternating the signs. So let's pull up the table. Bigger table. Okay, see what I mean by alternating the signs? Plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, I just happen to stop with plus the integral. So the negative means you change the sign. And this just happens to mean you add the integral rather than subtract it. So let's go ahead and walk it across. Let this be the derivative side and let this be the exponential side. Okay, I did forget the dx here, but as I integrate, this is why calculus students love e to the x, because integration, e to the x, e to the x, e to the x, e to the x. Easy. Derivative. Now, you see the first step, it was simpler. It went from a 4th power to a 3rd power. But we still have 2 terms. If we keep going, we're down to 1 term, but we have an x squared. Keep going. 72x. Derivative, 72. That's a constant, so why don't we stop there and write out our integration by parts. And I scooched it over a little bit because it gets hard. Okay, multiply on the diagonal. There we go. Oh, it didn't pop up. Okay. We're going to multiply on the diagonal, but we are going to change the sign. In this case, it's going to be negative. So we have 2 positives, and then we make it negative. Multiply on the diagonal, and it can stay positive. Multiply on the diagonal, and make sure you make it negative. Then finally, we have our plus integration sign, plus the integral of 72 e to the x, which should be pretty easy, right? Can't we just say that is 72 e to the x? Oh, plus c. Don't forget your plus c. And that's a great answer. I do not expect you to simplify. So, integration by parts, the good, the bad, and the ugly. This is one of the harder sections that we go over. So, it's all downhill from here, including the final. Good luck!